this is Britt Caswell with another example video. In today's video, we're covering example 3 from section 7-2 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to find the coordinates of a point on the unit circle. Alright, so with this, I really recommend making sure that you write the unit circle down and have it for quick reference. Alright, what I'm doing in this video is I'm showing you how to use the unit circle and special right triangles, but you know, having the unit circle handy if your teacher lets you use it is very nice. Alright, I have really bad aim, but there's my unit circle. So remember, a unit circle is a circle that is 1 unit in radius. Alright, so this is at 1, 0. Here's at -1, 0, 0, 1, for example. Okay, so there's kind of some of the stuff that you see here. And so what we're going to do is we're going to put an angle inside of this unit circle. Okay, so this one says that an angle has a degree, or a measure of 60 degrees. And so that's what I'm going to do. So remember, your initial side always lies on the positive x-axis. So there's my initial side. And my angle, which measures 60 degrees, is going to come chill up here. And what they're saying is when it's done that, this terminal side is going to hit the unit circle at some ordered pair x, y. And so what they want us to do is figure out what x and y are. Okay, so what I actually do for this is I'm going to drop a line down from that point to the x-axis. Now, because this is on a coordinate plane, you know that this line that I dropped down is the y value, and that this side that kind of goes along the x-axis is our x value. And so we have a right triangle here. Now, not only do I have a right triangle, I have a special right triangle. Oops. The special right triangle that we have here is a 30, 60, 90, which you know because they told us was a 60-degree angle. And so I'm going to use my knowledge of special right triangles to help me to actually get values for x and y here. Now recall, if I have a 30, 60, 90, oops, gotta use the right tool to draw these lines. Story of my life, y'all. It's probably more like that. Sorry, trying to draw a anatomically correct 30, 60, 90. So if you have a 30, 60, 90, you know that the short leg is x, the hypotenuse is 2x, and the long leg is x root 3. That's just knowledge that you should have in your brain now. And so because this special triangle is sitting inside of the unit circle, you know that the radius of this circle is 1. That's what we mean by unit. And so the hypotenuse of this triangle is 1. But it's also 2x according to our reference triangle. So if I set those two expressions equal to each other, the 1 from our unit circle and the 2x from our reference triangle, what I can do is I can figure out the exact value of x and then the exact value of y using my ratios. Alright, so to solve for x here, I just divide by 2, and I get that 1/2 is the length of my short leg. I'm going to go ahead and put that in here, 1/2. And then to get my long leg, which is my y value, I take that 1/2 and multiply it times the square root of 3. And so the way that we write that out is as root 3 over 2. So the ordered pair they're looking for is 1/2 and root 3 over 2. Now here's why this is important, which is kind of scooting ahead, but Savvas is also mentioning it in here as well, so I think it's a good time to mention it while we're at it. when we're talking about SOHCAHTOA, right, or sine, cosine, and tangent, you know, come on, pen, you know that the sine of an angle, which in this case we're going to talk about the sine of 60 degrees because that is our angle, is equal to the opposite over the hypotenuse. So our opposite is root 3 over 2, and I'd be dividing it by 1. And so anything divided by 1 is just itself. So here's our sine. So notice that our sine is just the y value. And so that's one of our key ideas here. So the sine of an angle is the y value. Now the cosine of this angle is going to be the adjacent divided by the hypotenuse. So 1/2 divided by 1, which is 1/2. So we can generalize this to say that the cosine of an angle is equal to x. And so that's going to be really important as we continue on, finding coordinates of points in the unit circle and stuff like that. All right, so here in the try it, now they're asking us to use our special right triangles again. So I'm going to go ahead and draw a unit circle, which I really just need to get a picture and cut and paste it over and over, but whatevs. So there's our unit circle. And so we have an angle that has a measure of 45 degrees. So here's my initial side along the x-axis. And then for 45 degrees, it's about halfway. So there we go. And they want this ordered pair x, y. Okay. So just like last time, I'm going to drop down my line to my x-axis and make a special right triangle. So this is a 45, 45, 90 right triangle. Now you know the hypotenuse of this is 1 because it's part of the radius of the triangle. But if I think about a special right triangle that's 45, 45, 90, here's my 45, 45, 90. Remember, it's isosceles, right? So my legs are the same length. And if I call those legs x, my hypotenuse is x root 2. So I can compare these hypotenuses. Hypotenuse, I don't actually know how to say the plural of hypotenuse. I'm going to call it hypotenuses. But if I set them equal to each other, I can actually solve for what one of these legs would be, what this x would be, and what this y would be. All right, so I'm going to divide both of these sides by root 2. Now, right now, what this is getting me is that x is equal to 1 over root 2. And we don't quite like that because we don't like radicals in the denominator of our fraction. So I'm going to multiply this expression by a value of 1 that cancels out that radical. So I'm multiplying by root 2 over root 2. Therefore, x is the square root of 2 divided by 2. Now, because x and y are the same thing, because this is a 45, 45, 90 right triangle, that means my y is root 2 over root 2. So the ordered pair is root 2 over 2, comma, root 2 over 2. So there we have it, guys. That is how to find the coordinates of a point using the unit circle. Until next time.